What we're going to show now is that if you've got a function, let's say f of x, and you multiply it by some value, we'll call it k, where k is a real number, then if you differentiate that guy with respect to x, this variable, that's equal to k times the derivative of f of x, which is equal to k times f prime of x. So that's what I'm gonna show here. Okay, so what we're gonna do is we're going to let some new function g be equal to k times f of x. And then what we're going to do is we're going to find g prime of x, and we're going to show that it's equal to k times f prime of x, where k is a constant. Okay, so the limits as delta x goes to 0 of g of x, well, of the difference, I shouldn't say of g of x, of g of x plus delta x minus g of x over delta x, that is by definition g prime of x. Now we need to show that this guy right here, this guy over here, is the same as this guy here. So what we're going to do is we'll do some inserting here, some substitution. So the limit as delta x goes to 0. Now g of x is equal to k times f of x. So that means g of x plus delta x is equal to k times f at x plus delta x. Do you see that? Because g of x is equal to k times f of x, so g of x plus delta x must be equal to k times f at x plus delta x. And likewise, g of x, we already know that that's equal to k times f of x. So let's go ahead and plug these guys in here. So this is going to give me k times f of x plus delta x minus k times f of x all over delta x. Now we can go ahead and we can factor out a k. So this is going to be the limit as delta x goes to 0 of k times f at x plus delta x minus f of x over delta x. Now using our product rule for limits, we get the following. We get this is equal to the limit as delta x goes to 0 of k times the limit as delta x goes to 0 of f at x plus delta x minus f of x over delta x. But this last one is the definition. Well, actually, okay, so this first one, k is a constant, so delta x goes to 0 of k is equal to just k. That's the limit. And this guy right here, well, that is our definition of the derivative of f of x. And so there we go. We've got g prime of x equaling to this. Now, in use, what does that give us? What it says is that if we have something like this, if we have h of x being equal to, let's say, 3 times x to the 6th, then h prime of x is equal to 3 times, now the derivative of this, because 3 is the constant, it can be pulled out here, and so it's just 6x to the 5th, which we already know is 18x to the 5th. So the whole point being is if you have a coefficient out in front, no problem, we can go ahead and we can multiply, we can bring that power down, multiply, and we get this value.